quite straightforward and quite simple, and this is probably one of the reasons why it's been so effective. Why I use the picture of zombies is that gossip protocols are often referred to as epidemic protocols, and it's for that reason that in the same way as you can spread a rumor, a virus also can transmit in the same way. So, this is actually a really good protocol. Back in 1989, a huge cluster, 3 whole servers, right? The protocol worked. It was proved it was very efficient for synchronizing email databases. And then later on, when things started to look in the SWIFT paper, we were working with 55 computers, which for 2002 was a huge number. Today, we can still use gossip. But today, we're using 5,000 nodes, 10,000 nodes. This protocol has proven itself over nearly 30 years and is still going strong. So how does it work? 2 simple rules. So what happens is, you've got all of the nodes in the cluster, and they're operating these synchronous rounds. And it's also assumed that each node knows the location of the other nodes. That location's kind of discovered through anti-entropy, and we sort of can take that out of the process so we get the efficiency. But in order for a message to propagate, what happens is, you get this informed node, and it chooses another node at random, completely at random, and it sends it the message. So in round 2, what you end up with are 2 informed nodes, and they do exactly the same. They choose 2 nodes at random, and they send the message on. Now, what you end up with in round 3 is, out of those 8 nodes, you've got half of the entire cluster is informed of the message. So they choose a node at random, they propagate the message. And of course, at the end of the 3rd round, we can see that all of the nodes are now informed. So it's a really efficient protocol, and we can actually sort of make a mathematical formula out of this. We can look at this and we can state that the number of rounds that it will take to propagate a message is O log n. Horrible maths. Not that complicated though. So let's break it down. So mathematically, what we're looking at is the logarithm of 8, which is the number of nodes, and that's divided by the logarithm base. In that instance, it's 2, because what we're doing is we're halving the number of nodes that need to be informed with every round. So with constant probability, what we can state is that if I have a cluster size of 8, it's going to take me 3 rounds before every node in the cluster is aware of the message. Now in reality, you're never really going to get constant probability, but the key thing is the more nodes that you